You're going with common denominator. So you guys have both options. Jamie was thinking sine over cosine for tangent first, and then Jackie was thinking common denominator first. So think about which one's easier to keep going. So with Jackie, if you guys look at it, see how there's tangents all over the place? What do you have to do with every single tangent? So I would maybe backtrack. Change it at the beginning, make it look nice and pretty, and then think common denominator. So you're right, they were both valid. Which one to do first is kind of like a, I think that way was the hard. Yeah. We've done some Look in here. I don't think we want cosine. So even though it was valid, I would change tangent to sine over cosine because I only want sines and cosines. Change. My bad. Go to sine over cosine. Simplify the cosine. Ryan's going, come on, sine over cosine, not cosine. Sine over cosine.
Come on, AJ. No.
Those just joining us, they were in the back of those spirals together and then
M and G, did you get it?
P and the top. So it looks like that's how you divide it. And
Let's just put like a real. Oh wait, no. Yeah.
How about the quotient property for tangent?
you multiply cosine.
How about the quotient property
Oh, that's what.
for tangent? That's what I would do. How about the quotient property for tangent? That's what I would do first. You could have done the common denominator first, but if you did that, don't you have tangents everywhere?
Yeah.
And you have to change all of those tangents. And that's not bad. You took a step and it was mathematically good, but it just made it harder. Backtrack, get rid of the tangent first, using sine over cosine. Not as is, because you need to get common denominators first. It'd be this guy divided by parentheses, that guy, and I need to get it together. Or, I think George was trying to describe my trick from yesterday, complex fractions, right guys? Jordan, can you explain it? What would be maybe one way to go?
Well, what I would do is I would circle the cosine x, and then I'll multiply it to the top and the bottom.
If you want to use my trick, which does not involve you having to get common denominators or multiplying by reciprocals, that would be my trick. Who was making this a complex fraction? That guy. Take that guy, multiply top and bottom. Remember, we have to put the parentheses no matter what. And then, don't need to do anything here, because we don't know the common denominator yet, so just leave him as is. Now pause. What happens to the numerator? Cosine squared. Just the sine. With parentheses and subtraction, what do I have to do with that cosine? Do I have to distribute him?
Yeah.
And what's cosine x times 1?
Cosine x.
And what happens when I bring him in here? The cosines cancel. If you need to, you can put him like a little over 1 and him a little over 1. So long story short, this cosine is on top, in a sense, of the denominator. So when I come in, these two will cancel, only sine is left. Hey, is this starting to look kind of like it should?
Yeah. It does.
It's getting close. Sines are a little off, but getting close. Now, might it be, now that it's closer, might it be a good thing to do a common denominator?
Yes.
Now go for it. You need a little more time.
But isn't it supposed to be sine minus cosine?
Now's a great time for a common denominator.
Isn't it supposed to be sine minus cosine though?
So if you want, you could factor out a negative. So if you pull a negative away from a positive out, they'll flip both signs. Could factor out a negative, or you could, if you want, multiply top and bottom by a -1, which would also flip the signs. Then common denominator, or you could do common denominator and fix it later. Either way works. I'll probably do common denominator, fix it later, because some people didn't realize it yet. Because the first cosine is over 1, right? So we need a common denominator.
Is it 1 minus?
I'm subscribing on this one. I had subscribed.
You guys agree with my common denominator even though it's messy? He's over 1, you need this guy, so top and bottom. What do you guys think I'm going to do with this cosine right here? Cosine times cosine? Cosine times sine? Just stuck, I can't put them together. What happens as soon as I have common denominators? Yeah, some of you might have skipped this step, but for some, I'm just trying to make sure you understand. Leo, what step are you on, bud?
I'm on the last one.
Okay, good. Just making sure it's making sense. Now I can put them all together, and what happens, kiddos, when I do cosine squared, a positive cosine squared, minus sine cosine, and then a negative cosine squared? Good. Now what is different as I look at the final and what I have?
There's a negative sign.
The signs are different. The signs are different. Now here's a creative way of dealing with that. The uncreative way, we could do something on the denominator. We could actually factor out a -1. Divide both by a negative, factor out a -1. But for most of you, it'd be easier to be creative and say, if we ever need to flip signs of an equation, we could multiply both sides by -1. But since we have everything on one side, we could do our top-bottom, multiply top-bottom trick, and we could multiply top and bottom by a -1.
Yes.
That's how we can flip the signs without working with both sides of an equation. Instead of multiplying both sides, we can do our cool top-bottom trick that maintains the balance. And if you multiply the top by a negative, what's a negative times a negative?
Positive.
Hey, this sign's flipped. Perfect. And on the denominator, or for the denominator, if I multiply both by a negative,
Negative cosine.
the cosine's going to be negative, like I want it to be.
Yes.
The sign's going to be positive. You could write it negative cosine x plus sine. But I can't spell cosine x. And then when you look at the answer, you're like, oh, but they write it the other direction. But the sign is still positive, the cosine's still negative. We're good. Once again, some of you might have seen this earlier and been able to jump to the last step. That's okay. As long as you know how, you could repeat it if you needed to. I don't mind, because I can definitely follow that work.
Okay.
Whew. What skills did you need for this problem? Well, but you can't just tell a second grader to use your brain, right?
Problem solving.
There's a lot of stuff that went into this. You need more than problem solving. Something specific. Okay, AJ, give me a specific identity you needed.
Physical.
Sure.
Oh,
We didn't actually use that one.
Quotient.
Quotient, good.
Yeah.
Quotient, we changed tangent to sine over cosine. What's another skill that we needed? Yeah, multiplying top bottom to get what? There were two different things we did with that. What were we doing here? Simplifying, and who is this guy? A fraction and a fraction?
Complex fraction.
Okay, so good. So we had to develop the skill, use the skill, apply the skill of simplifying complex fractions. We multiplied top and bottom to do that. But what were we doing here? We were also doing another skill. So we multiplied top bottom for a complex fraction, multiplied top bottom for a common denominator, and multiplied top bottom to switch the signs. I don't even think we used any other identities, did we?
No.
We just did math. The only identity was the quotient. Question. How many of you guys can see that you have improved working with trig expressions, just working with them? I'm not even saying specifically you're acing the common denominator every time or you're acing the complex fraction, but how many of you guys can at least say that you could see some improvement in your ability to work with complex expressions as far as moving, transforming, plugging in? Some improvement from the very first day that we did these. Okay, majority of the good. Remember 5-1 when I was like, guess what? We can add stuff. No. We can factor stuff. We can do common denominators. 5-1, we were just like, oh, we can do stuff with a trig. Yeah. 5-2, you guys are doing like crazy problems with all these different steps, putting it all together. Where'd you guys get stuck? Oh, sorry. Yeah, it's this one, Joe. It's the other denominator, this guy. Cosine minus sine. Yeah, I wrote it way too small. I apologize. Okay, back in our notes. We had 3 more examples to do today. We just did 1. 2 more. 2 more, and then workday. Hopefully you guys have your books close. Because this one's going to go super fast. The next one maybe a little bit longer. As soon as we finish our last example, those of you guys who leave your books at home, come on up and grab a textbook. As soon as we finish, not this one, but the next example, I'll let you know. Just be ready. In your homework spiral, hopefully you're keeping it close, because remember, we're going to get back into the work. You guys know what to do. Write it, draw a T, pick a side. That's exactly how you're going to be able to start. It's how you should start the quiz that's coming on Thursday. 5-1 and 5-2 alone. You want to try? You do the right side? Then I'll give you the answer to the left side. Let's see. Okay. While you guys are working on the left side, I'll go ahead and do the right side, but I'll have it covered by the projector screen. How about that?
Just using this.
Help me out. What's the problem? Tangent of? Time. No, it was here. Anyway, as I do this problem behind the screen, I want you guys to choose the left side, please, but pause. Choose the left side. You better get back to section 5.1, the table. Even those of you guys that know the formulas like this, you're going to want to look. 5.1, look at the table. Ready, set, go.
Yeah, it was fun.
I'll even do better. You guys done? I told you to look at 5.1, the formula.
backwards in the way.
Oh,
Excuse me?
How should your proof look?
Like
This
Oh, look at that.
to that
So that.
to that.
to that, unless. You want to change this to 1 over tangent first, and then cancel and get 1. That's very good. But how on earth do I go from here to here?
There's the property.
Co-function property, section 5.1 table. Co-function property. Tangent of pi over 2 minus mu or minus theta is cotangent. So, let me get back to going from the left to the right, and let's see if this is still somewhat aligned, which I doubt it, but that's alright, we'll try. Without that co-function property, what would you do? Nothing legal. Because if you think you can take this little guy and distribute him and say you're tan and you're tan, no, that doesn't work. That's not tan times. Do you remember how we read it? This is tan. No multiplying. Sorry, some of you thought that was a thing. Totally not. So, tangent. That's close. Co-function property says this whole guy is this guy. If you want to make it super nice and super clear, even to younger kids, maybe not super young, but younger, you could then use the, what, reciprocal property? To say cotan is 1 over tan. And what happens when I have tan over tan? Good. It reduces tan to 1. But, once again, if you have not yet looked at your 5.1 table and looked at the co-function property, of course it's not going to make sense. You gotta know those properties to be able to solve. Check QED. Thus it has been proven. The check is my fast way of doing QED. It's like a thus it has been proven my way.
Or
Mr. James FaceTime. Or George Corey Rubber. Or something else random. Okay. Guys, was this proof hard? But could you have done it without the properties? Not legally. Not legally. It would have gone horribly wrong. Last one. Woo! Last one. This one we're doing together, don't worry. This one we're doing together. Because this one takes a bit more creativity. But maybe it won't look that new. Maybe it won't look that new. Yeah, Jordan, I put you in your group for a reason. Make sure you're helping and working with them. Okay. Those of you that are like, hey, I've been getting all of these. Cool. Go ahead and get a little bit of a head start. For the rest of you, this one's hard. We're going to work together on it. Okay? I'm going to move him over, actually, just so you have lots of room. You might not agree with me, just trust me on this, okay? Choose the left side. The left side has a square root. The right side doesn't. You need to somehow get rid of that square root. Now the sad thing is, you cannot use a Pythagorean. The sad thing is, since neither of these are squared, we cannot use a Pythagorean. But that doesn't mean we can't do anything. I'm actually going to change the color just to make it like we've been doing kind of all day. Haven't we been, in a lot of these problems, multiplying top and bottom by the same thing?
Yeah.
I'm going to do that here too. So here's why I'm doing it. Let me show you what I do first, then let me show you why. See if you can figure out the why. I had 2 different expressions to choose from. I mean, I could have chosen sine over sine, cosine over cosine, I could have chosen all sorts of things. But why did I choose to multiply by this guy? Top and bottom, I could have chosen anything. Put a square root, talk about that too, but why this guy. Chris, what do you see?
Because on the problem we're trying to get to is 1 plus sine of theta in the numerator, and for squaring both the numerator and denominator, it has to be the square of 1 plus sine.
So Chris is seeing this stays. If I have a square root, for this to stay, he has to get multiplied by himself. He has to be squared. And here's the trick. If I can't play with both sides, I can't do this nifty like, hey, square both sides. I'm not allowed to touch him. I'm not allowed to play with him. Not unless I give up on this one entirely and I go to this one, but then I'm not allowed to touch that one. I can't square both sides. That's illegal in proving trig identities. But what I can do is say, oh, hey, you want to stick around? Well, you better get multiplied by yourself. But what I do on top, what I do on top, I have to do on bottom. So I couldn't rewrite this one. That'd be totally illegal. But I am allowed to do same top bottom. The square root, why did I put that? Because otherwise it couldn't join forces. This one has a square root. Well, I had to have these ones have a square root also. And then look and see what can happen. I can put one big square root, since they all have square roots. Since they all have square roots. If you don't trust me on that, let me give you something like this. Square root of 4 times square root of 9. What would that be? 2 ways of doing it. One way is to say, oh, hey, that's going to be 2 times 3, right? Which is 6. The other way of doing it is, oh, hey, isn't that square root of 36? Which is 6.
Yeah.
I'm allowed to multiply square roots together. I'm allowed to divide square roots together. So I'm allowed to make one big square root and say, oh, hey, you're joining forces with you? Cool, that's going to be 1 plus sine times 1 plus sine, aka 1 plus sine squared. I'm allowed to join square roots together like I'm doing here. On the denominator, I'm going to have 1 minus sine times 1 plus sine. Here's another question. The square roots. I just have to remind you guys, since we haven't done a lot of square roots this year. What would be the square root of 9 over 4? All of it's under the square root, the whole thing. It would be 3 over 2, which would be the same thing as square root of 9 over square root of 4, right? If it's one big one, I'm allowed to split it up and take the square root of the top, square root of the bottom. Because this whole thing had to be squared to get there, to 9/4. Same thing here. I'm going to split up the square root of the top and split up the square root of the bottom. But let's see, guys, cosine. I don't think I can leave it as is. What other option do I have? What can I do with 1 minus sine times 1 plus sine? I can FOIL it out. Any mental maths? Have you already gotten there? It's difference of squares. First is 1, outer, inner. Sine minus sine cancels. It's going to be first and last only. Oh, come on, my property people. What's 1 minus sine squared? There's a square. Now it's legal. Yeah. Some of you are looking at the Pythagorean if you don't have it memorized because you know where to look. The rest of you guys are like, wait, I know that one. It's cosine squared. And now some tricky math comes into play, although you think it looks so easy. Some tricky math comes into play. The easy part is square root squared, what happens? Mm-hmm. You're like, oh, I see everything, but why on earth in a denominator are there absolute value bars? I need it to match 1 plus sine of theta all over the absolute value of cosine theta. Well, here's the struggle. That comes back to something that we had to review a few days ago. Something in younger algebras teachers tend to leave out, or they cover it and you just kind of block it because you don't like it. Square root square, they are inverses of each other, except a negative will never possibly come out of this expression. This is the positive principal square root of a square. Negative times a negative, positive times a positive, always positive. Square rooted, always positive. When I take away the square, the always positive goes away. I need it to stay, always positive. So in essence, I can cross off the square root squared, the square root squared, and get absolute value of 1 plus sine all over absolute value of cosine. But stink, that doesn't work either. Because there's no absolute value. What? Does anybody remember how high sine goes and how low it goes? Normal little sine curve. Goes up to and goes down to. If I did 1 plus 1, that'd be a positive number, right? If I did 1 plus a half, or 1 plus negative a half, or 1 plus root 3 over 2, or 1 minus root 3 over 2, or 1 minus 1, that's a 0. Can I ever get negative if sine is not allowed to go any lower than negative 1? I need to take away like negative 1.1 or negative 2 or take away like, or add negative 3. Sine will never make this whole thing negative. So since it can never go negative, the absolute value bars are redundant. It's keeping something positive that's always 0 or positive. So there's no point to absolute values. They take them away. They take them away. Because it's okay as is. Kiddos, I did this one for a very particular reason. I think I gave you 1 in homework, and the only reason I did that is because we got to work out 1 together. It's tricky. Square root's kind of weird. And the green and something creative was kind of weird too. Hopefully you kind of got the logic to it. We still have 15 minutes. I'm done. People that need a book, go grab it. We left it at home. And those of you guys that brought your book, if it's in your locker, give me a quick sec. We might have enough for you to get it. People who need it, get it out here. I'm going to walk around. Oh, because you finished and worked it out. Alright, anybody else who needs a book? I think we have enough for you to borrow one, so come on up if you left it in your locker. I'm going to pull up the questions in case you didn't get them all written down yet. Nice thing is there are not a lot of directions in these ones, guys. It's pretty much like what? Solve? Verify? Alright, homework problems for 5.2. I'm going to be very strict with you using this time wisely. If you can show me the entire homework attempted, I think I have at least 1. I'm going to use you and pair you up with a group that might have been struggling a little bit today in class. That way you can answer questions while you kind of just sit and try it. But if you do not have the entire homework assignment attempted, just show me here in class. Because I told you to bring your book and your homework so that we can go over questions. You need to get going on it. And if you're stuck, I'm here. There were some kids that were in here yesterday after school working on it. Was I willing to answer any and every question? Yes, I was. So, ready, set, keep working. Some of you sadly maybe start working. And then, if you can show me the entire homework, I'm going to kind of walk around, just kind of get my attention and be like, look, I attempted it all, sweet. I'll pair you up with a group that was struggling a little bit. And you can be like, hey guys, if you need anything, I'm right here. Cool. Alright, let me walk around the room really quickly just to see those of you that do have it fully attempted, and then I'll take specific questions that you guys already have from homework. Those of you guys that did get to work on homework, let me get some numbers from you that you're stuck on currently. Randy, you're stuck on which one? 22. 22. Josh, which one are you stuck on? Anybody else currently stuck on one or not so sure about one? Yeah. 17. Okay. Thanks, Josh. Yeah. 20.
She's helping us do those.
Anything else you're stuck on currently? I'm sure we'll have more tomorrow. Make sure you get the assignment down. It's only going to be up for a couple more seconds. I'm going to go see which ones people are stuck on. Or have to do like a copy now. Since I'm moving to DJ, Josh, why don't I move you in between Joe and Ryan? That way you're available to answer something if everyone wanted to do it.
Just helping us.
Since I took AJ, right, and you can still be.
It's just probably.
Oh, you can go over first and then. Not yet.
Yeah.
Yeah, it just sounds almost
Last night I got stuck on 60.
And it was the square root one, right? Yeah, it's hard. Because you chose, the square root was on the right side. Well, then you chose the right thing. I'm sorry.
Questions like left side, left side, left side.
And then all of a sudden the right side, yeah. You're not ready for it?
I feel like choosing, not wrong, I feel like choosing which side to do is probably, yeah.
It's very strategic. Like some of them are super obvious, but otherwise it's super strategic to figure out whether one is better to choose than the other. We have 17, 20, and 22. Okay.
The very first critical action is to choose to be critical. Very critical. Like if you give me a test right now, I'll probably that's it. Or at least like 50. It's my super. So she's gonna get to us on Wednesday.
Okay, guys, remember, be using your T's. Your T-proof, choosing a side. Don't do it exactly like the book. The book does these weird, like, equals, and that goes all over the place. Just super awkward. Alright, now people with questions. I might not do the whole thing, but I'll get you started. 17, 20, and 22. I'm going to put it all up here on one page. That way you guys can take a picture of it before you leave if you haven't gotten this far. But for those of you that have, I think 17, for those of you that were there, I would have chosen the left. Right? I'm not afraid of complex fractions, so I think I would have gone with a complex fraction quotient property and reciprocal property. I would have gone with the quotient property and reciprocal. I'm not saying it's the only way. That's just probably what I would have done. Because I see the sine and tangent. I don't see secant, so I'm like, let me get rid of him. And then if you think about my trick, I would have seen a cosine and a cosine squared. You could have multiplied top and bottom by a cosine cubed, multiplying the two. But think common denominators. I would have just made this one a cosine squared. You could also think multiplying by the reciprocal. That works also. If you're thinking my trick and trying to get good at it. That's what I would have multiplied top and bottom by. And then you're well on your way. of finishing it off. So let me stop there for right now. That cosine would cancel with one of those. Both of those would cancel with both of those. With sine squared over cosine, my hint, make sine squared sine times sine. My hint, make sine squared sine times sine. See if that works. Week number 20, I'm choosing the left also. I'm not saying the left's always the best one to choose, but I chose the right. The right could have worked too. I kind of see the ability to do a common denominator on the left. That's why I'm choosing it. You would have gotten a common denominator. Oh, I can't finish this one. That would just be highway robbery. Think Pythagorean. Think Pythagorean. The answer's right there. Think Pythagorean. Go to your table. The answer's right there. 22. It makes it a little bigger. Sorry, guys. I would choose the left. Some of you did some illegal craziness in trying this one. Oh, you just were scared of it. I tried it. But those of you that tried it, it was a little weird.
How do you think I got?
But in this one, the parentheses just mean times. There's no distribution because there's no plus or minus in there. It's just times. So you could rewrite it as secant to the 6th times another secant times tangent. Well, there's no distribution inside here. So you just make it secant to the 7th. Say, okay, whatever, you wrote it funny, but there's 6 there and 1 there, so there's 7 altogether. And for this one, there's 4 there and 1 there. All right, fine, there's 5 altogether. No distribution, no adding or subtracting. Put it all together. But if you look over here, say, whoa, how did they? Huh? I do see 2 terms. And I do see some stuff shared. Maybe we should. Why am I putting a parenthesis? Let's factor what's in common. I don't know what else to do. I can't put them together. They're not like terms. But I can say, fine, there are 5 secants that are shared. They can pull out a secant to the 5th. Okay, that's that guy. There's 1 tangent that's shared. All right, fine, I'll pull him out. And when I divide away 5 from the 7 under there, I'm going to have 2 left. The tangent's gone. And I pulled away all 5 of the secants and the 1 tangent. I can't finish that one either. You just got to go look at the Pythagorean. Right there. Since I have had time to look at all 3 of those, I'll come back to 17 because he gets a little funny. I'll come back to 17, maybe finish him. He does get a little funny. All of that reduces, that takes away all of them. I'm going to cheat just a little bit for those of you that are on 17 with me. I'm going to cheat just a little bit. I'm going to look over here and say, sine, I got one. Tangent, quotient property says, tangent is right there. Sine over cosine is tangent. Exactly. Questions? Jacob, go ahead.
Number 17, I don't know if I'm allowed to do this.
That's okay. What'd you do?
So for the tangent squared,
Yeah.
I just use that the tangent times tangent over
Okay.
1 over cosine.
Nice.
And then I changed one of the tangents to sine over cosine.
Nice.
And since they're both over cosine, I canceled out the cosine. So it was just sine times tangent over 1.
No, you're good. You're good. I probably would have done my trick of circling the cosine and multiplying to make sure that we didn't make any mistakes, but you're right, because the 1 over cosine would flip and then it would cancel. Or you can see they're shared and you can reduce. That's good. That was actually a very creative way to do it, so good job. The other way I can see a lot of people doing it might be secant squared minus 1. That gets a little rough. It's still possible, but it gets a little rough. Kiddos, if you're not up to 17, 20, or 22, I would take a picture. It is in the video. Listen to me do it tonight, but if you're not going to make that extra action step of looking it up, take a picture. Take a picture. How many of you guys have gotten through at least half of homework? Like you feel like you've done a pretty good job. Okay, good. That's at least half the class, and that's not to necessarily, it's to encourage the other half. You could have been there if you had just started early. But second of all, it's possible. They've gotten that far, and we only have 3 questions today. Okay, it's possible. Have your notes close. Have the formulas close. Have the examples close. I'll be here after school to take questions. Great job, guys. I'll see you tomorrow. Bring your questions at once you get stuck on, and return my books.